And the last one, not the least. So my topic is how to use a social media network to enhance the recommendation and search for the multimedia objects. And I will focus on the unified entity method. So here is the content that I will talk about. The first one is the motivation that we use the social multimedia computing to exploit the content and context in the social media network to help enhance the recommendation and search, because since with the proliferation of the user-generated multimedia content like image, video, nowadays the social media network is so heterogeneous and large scale. So using the traditional method, the keyword search or the tagging method using the text surrounding the image to tag the image, it's so hard for you to search for a certain entity in the social network or recommend them. So it's better that we can use the context in the social media, which means that the user's behaviors, actions, the relations around him to help the search and recommendation. So, well, they have already talked about many stuff about the content and context-based method. So, for the content-based method, it's just about what Wolfgang has said. To extract the semantic information from the image, the video, or the audio, the music, and to use all these semantic information, the features to type all this stuff. So the basic idea is to transform from the keyword tagging to the semantic tagging. And we have some techniques to do this stuff. So I won't tell about the advantage of it. I just tell about the disadvantage of it, because the limitation of the technique, like the computer vision technology or the acoustic analysis technique or something. So we can't extract the semantic information exactly to describe the multimedia objects, because I think for the computer it can't understand the multimedia stuff exactly. So it's a drawback of the content-based approach. So it can't satisfy the need for recommendation and tagging. And for context-based search, there are nowadays we have the collaborative tagging system to tag the multimedia stuff, like the users can tag a video or an image from their perspective to describe it. And also we have the collaborative filtering system. We can use the relationships, the behaviors and actions of the user to recommend some stuff to this user. And we have some methods. But the drawback of this method, I think it has two aspects of the drawback. The first one is that many researchers are only restricted into a certain domain of the entities. Like some researchers only focus on the users and text, some focus on the text and images. And so if you want to recommend a stuff to a user, if the user is not active in the social network, so in a certain domain there, we can't get enough interesting information of this user to recommend a proper stuff to him. We have to transfer the information from other domains to this domain to help recommend it. So we should regard the social network as a whole and rely on all the entities in the social network to help recommend and search. And another aspect of the drawback is that nowadays the research regard the friend recommendation, the type recommendation, and the personalized recommendation separately. For example, if you, the researchers, if you want to research on the friend recommendation, at first you should maybe build a user profile and recommend some friend to him. And for the image tagging, is another research method. But I'm wondering whether we can use a single way to solve all the three problems to solve the friend recommendation, the image recommendation, and personalized recommendation in a single way. So many researchers have proposed the unified entity recommendation or research system to solve this problem. The basic idea is that they regard all the entities, the users, the images, the tags equally. And in this way, all the three types of recommendation can be transformed to a single problem, the query search problem. For example, in the first graph, the query type is the user, and the search results are also the users. So in this way, we can recommend the users to this user. And the second is the query type is the image, and the search results will be the text. So likewise, the third graph, the query type is a user and the type, and the search results are the images. In this way, we can regard all the three types of recommendation in a single way. So in order to solve this problem, we have to at first construct a unified entity framework. So there are three types of algorithm to solve this problem. The first one is a unified hypergraph algorithm. And from here you can see that actually it's a generalization of the ordinary graph, but in a hypergraph, the edge are called the hyperedge. The hyperedge can represent the high-order relationships among all these entities, because in a social network, the relationships among the entities are really complex. So we can't just use a pairwise relationship to represent it, like a user to an image, user to a type. But using this method, using a hyperedge, in each hyperedge, all these the types, the items, and the users have a high-order relationship. So some researchers have already proposed some methods to construct it. The first one is proposed by Hu, and he applied this framework to the item recommendation, put simply the music recommendation. And he used the social media information, which means the type context in the social media network, and also he used the music acoustic with the content. He extracts some features from the music in order to find the similarities among the different music tracks. So he combined the content-based method and the context-based method, and he transformed the recommendation problem into a ranking scale of the vertex problem. He regards all the entities in a data set, the users group text, the 6 types of entities as the vertex. And he also extracts the relationships among them as the hyper edges. So you can imagine that if two vertex are in a contained in many common hyper edges, we can make sure that the two vertex can have a similar ranking scores given a query vector. So it's like if two music tracks are liked by many common users, we can make sure that, or we can imagine that the two music tracks have a similar ranking scores. So based on this basic idea, the researcher proposed a regularization framework to try to build a causal function, and by minimizing the causal function, we can set different ranking scores to all the entities, giving a Perry vector. And I think this method has some drawbacks, has some disadvantages. The first one is that in this paper, the authors treat all the relationships in the hypergraph equally, which means that they hide the same weight to the hyperedge in the hypergraph. But we all know that it's impossible because the relationships should have different importance. We can't regard a user to a user to an image, or the image to the type, the relationships among them totally equally. So it's impossible. So I think this is the biggest flaw of this paper. And the second one is just extract some basic music feature. So it doesn't exploit too much multimedia content from the music. So this paper, I think the researchers improved the method proposed by Book in two aspects. The first one is that, and in this context, the researchers apply the hypergraph into the image retrieval application. And at first, they improved the method by exploiting more visual information. From here, you can see they extract more visual features from the images to try to build the similarity matrix between the images. I think this is one improvement. The second one is that they propose a semi-supervised learning method. In using this method, they can calculate the ranking scores of the vertex as well as the weights of the hyperedges at the same time. So in this way, they can make sure that the hyperedges have different weights, which means that we can the relationships among different entities are different. So these are two improvements. But the drawback of this method, I think the first one is if you in this semi-supervised learning process, their method is to calculate the weights of the hyperedges and the ranking scores of the vertex iteratively many times. This will surely increase the computation complexity. So because the search system is a real-time response system, so we all want to search for something and we can get the result immediately. But you can see in this method, they increase the time dramatically because they have to calculate many times. So even though that the accuracy of the results, the performance of the algorithm increase, but the efficiency decrease. So I think they have to find a balance between the accuracy and the efficiency of this algorithm. And the second one is, from my perspective, they don't take the diversification of the social image search into consideration, because I think all the researches only focus on to find the most related image searches, images. But due to the semantic ambiguity, because we are searching for some images, we can't describe it very exactly, clearly, and due to the reason of the taxonomy, there must be some semantic ambiguity in it. So many users may hope to get the results, the diverse results, not just the results that most related. So this diversification problem is resulted from, at first, the semantic ambiguity of the query, and the second one is the similarity between the multimedia objects. For example, the similarities between the images. So I think in order to solve this problem, one solution is try to exploit the semantic information of the images, which means that we should extract more features from the images to try to describe them clearly. So in this method, they extract the 11 feature descriptors from the image, and they can, in this way, they can find the correlation among the images very exactly. And they also use a probability hypergraph method, and they use a clustering algorithm, and they form the hypergraph with the most similar images. In this way, in one hypergraph, all the images, the correlation of the images are really high. So in this way, they make sure that I think they some kind solve the problem of the diversification. And some other researchers have also applied this algorithm to the personalized recommendation. And their basic idea is to put a user in one hyperedge and capture all the related information with this user into the same hyperedge. And in this way, and they also define the concept of news capsule. Well, this application is for recommend the news to a user. So in one hyperedge, there is a user and all the information about this user, which can show his preference and interest. And this capsule is called can represent the user's profile. And the second is to given some articles, and we compare the similarity between the article and the user profile, we can recommend some certain articles to this user. So they solve this problem by using this way. But there are also some drawbacks of this method. The first one is that they only extract the reading history of the users, not other social information. And the second one is computation complexity is still very high, because every time you introduce an article into this hypergraph, you have to reform all the news capsule one time. The whole every news capsule have to be recalculated and reformed. So I think this efficiency is so low. And in conclusion, I think for the hypergraph algorithm, well, there are some advantages. We can find the social information can enhance the recommendation performance. And another is that the different, well, compared to the first paper, the following papers all use some learning algorithm to cite different ways to the hyperedge, and this will and the performance of different ways of the high-order relationships is much better than just assigning identical ways to all the hyper edges. But of course, this will surely increase the computation complexity. So how to find a balance between the efficiency and the accuracy is very important. And I think there should be some improvements for this algorithm. The first one is that we should consider more relationships, inclusion relationships, and more actions of the users into account, because all the researchers all use the very small data set from the last .fm, in which there are only